Hello and welcome back to Project Java. This is Venkat and today we'll be talking about binary trees and depth first search. This depth first search traversal algorithm is really important for your board exams as well as your gate exams. So without any delay, let's begin. So firstly, let's talk about the agenda of this particular video. We'll be talking about tree in and post order tree walkers as well as depth first search. But firstly, what is it? So the depth first search is a recursive traversal algorithm. It is used for trees and graphs specifically, and it visits all the nodes deep in each branches before it explores to the other branch. So let's say that here we have one root node. If I am using a depth first search traversal algorithm, so it'll jump here. If it finds that there is another node and it's not the leaf node, then it'll jump here. Again, it finds that there is no child node and this particular node is a leaf node. So it'll print this node and then the function call will go to the middle element. Then the middle element will allow another recursive function to take place and to explore the rightmost part of the entire tree. And then again, this way it goes till the depth of a tree, prints the element, and then returns back to its caller function. So this is what depth first search is all about. There are three types of DFS: pre, in, and post order respectively. The only thing to change here is the middle element. In a pre-order, we have the middle element in the center. In pre-order, we have the middle element in very left as the first element, followed by left and right. In order, we have the middle value node at the center, left precedes it, and right succeeds it. In post-order traversal, we have the middle node value at the very end of the order. So this was all about pre, in, and post-order traversals. Now let's see what trick should we use so that we get our desired traversal output.
So let's begin with the traversal of this particular tree using the trick. Now there are three steps in the trick. The first step is wherever you find leaf nodes, you will just draw two lines protruding out of these nodes. Okay, let's say that there is a node like this. It has a left subtree, but it does not have a right. Like it has a right subtree, but it does not have a left node. So you will draw a left node here. You just need to make sure that there are lines in the places where there are no left or right or either of the two trees present. So we complete this particular tree like this. This is the first step. We have completed it. Now, the second step. The second step, you'll write in pre, in, and post order. And you'll number them like this. First is pre, second is in, third is post. It's really easy to remember this because pre, in, and post. You get it. Now, we have completed two steps already. What is the third step? Well, if you can guess, we'll start visiting these nodes one by one. Now, there is one thing here. If you visit the node for the first time, you write it in pre-order. If you visit it for the second time, you write it in order. And if you are visiting the node for the third time, you'll write it in post order. So how exactly will you go about it? So first we visit the root node, which is A. We visit it for the first time, so we write it in pre-order. Then we go on to I for the first time, so we write it in pre-order. For the second time, we are here at I, so we write it here. Third time in post order. We go to A for the second time in order. Then we go to the right subtree. We visit B. Then we again go this way. We visit C for the first time. We visit C for the second time. For the third time, we visit B for the second time, and this way it continues. Then we go to D. Now when you go to D, it is the first time that we are visiting this node. So we write it in pre-order, then we come to E, then to G, then to G here in order, G here in post order, E here in order, H for the first time, H for the second time, H for the third time, E for the wait a second, we have written here E, so E for the third time because we are visiting it for the third time, D for the second time, F for the first time, F second time, F third time, then we go back to D for the third time, B for the third time, and then A. Now these three are the exact same order in which if you write a code, you will get an answer. So you might ask, what is the code for this? Why are we not talking about the code? You are viewers who have interests in different programming languages. So I'll prefer giving you an algorithm. So let's talk about the in-order algorithm for once. You can really comment down the pre and post order algorithms for traversing these kind of trees in the comment section below. So let's say we are doing an in-order tree walk. And we have a node. Okay. Now we need to check a condition. What is the condition? The condition being if there is a leaf node, or if a node, let's say X, it does not have any of its, like sub tree. Let's say if it does not have the right subtree, it's not there, or the left subtree is missing, either of them, or if both of them are missing, then your program might throw a null pointer exception. In order to handle this exception, you need to explicitly mention as a base case of recursion that node is not null. Well, if the node is not null, then you might say that we'll traverse the tree in the given order. So we first write in order tree walk for node of left, then we print the middle node element, and then again recursively we walk through the right subtree of the node if present. And that's it. There you go. This is the in-order tree walker algorithm for depth first search in a binary tree. It's kind of the same for graphs as well. So why in order are we traversing for the left side, then printing the middle, and then in the right side? So well, I have told you the order in the presentation already. It follows the left node first, then the middle node, and then the rightmost node. And it goes in this order. As you can see, in order, we have the leftmost element first, then we have the middle element, and then we have the rightmost element. So that's it for this video. I hope you liked this. And let's get back to the presentation once again. Thank you.
That's all for this presentation. If you like this video, please subscribe and do share it with all of your friends so that they can score well in exams. Thank you.